Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, let us try to understand the concept of rack awareness in Kafka. Okay, so already while discussing HDFS or Hadoop distributed file system, we encountered this particular concept and we explored in detail what is it. If you want to know the detailed explanation, you can check the link given in the description box. So just a quick recap of rack awareness. Like for example, suppose this is our data center where our HDFS is sitting. Here multiple racks are available. Okay, within racks multiple data nodes are available, right? Now suppose you have configured your HDFS such that whenever a block will be written in any data node, to make the system more fail-safe, we will take two more replicas in other data nodes, right? Like for example, one particular block is written in this data node 1 in rack 1. Okay, so to make the system fail-safe, the same block we will be copying or replicating in some other data nodes also. Like for example, in the rack 2, here the same data will be copied, okay, in the data node 5, and maybe here somewhere in data node 6 also the data will be copied. Okay, and while copying, what point our HDFS is taking care of? That where it is replicating the data, that data node should not be coming under same rack. Like here, suppose if the main replica is available in data node 1, then it will not replicate the data at data node 3, because the data node 3 is available in same rack where our data node 1 is available, right? So what problem we might encounter, that is, for example, suppose this particular data node 1 has a problem, then there is a possibility that the whole rack has a problem. Maybe whole rack is sitting within a particular room, and that room has electricity issue, or the room caught fire, something, whatever problem might appear, right? So the replication happens always such a way that main replica will be sitting in one rack in one data node, the other two replicas will be sitting in some other rack, and that two replicas will be sitting not in same data node in that other rack. Okay, so that property is also maintained here. So that is basically fundamentals of rack awareness. So same concept is implemented in Kafka. In Kafka, different topic partitions will replicate across multiple brokers, right? So let me draw in case of Kafka the architecture. So suppose for example, here I am drawing roughly. Suppose here we are having our rack 1. And here we are having our rack. Okay. Within rack 1, we are having two brokers running. Suppose this broker is B0 and this broker is B1, and another broker is running here. Suppose that is B2. Okay, right? Now suppose you have created the Kafka topic such that it will be having two replication. So what will happen? For example, here one partition is there where the data is coming in that Kafka topic. Now because that particular partition is available in B0, right? And we are configuring replication factor 2. So for the partition, another replica has to be created, right? So what the rack awareness is saying, that particular replica will not be created in R1 again. Why? Because same problem, like for example, that partition replica is created in another broker in same rack, that is suppose B1 broker. Then what problem might appear? That suppose the whole rack goes down due to fire or electricity problem, whatever, then the complete data will be inaccessible. So to avoid this issue, what happens? That suppose we are having one partition stored here, then its replica will be stored in some other rack. Okay, that is in another broker is running in R2 rack, right? B2. So in B2, the replicated data will be stored. Okay, suppose there is some which is in B1, I can show like this kind of curly way. So suppose this is one particular partition created. So for this partition, the replica will be created in B2. So what are the possible combination? If one particular partition is available in B0, the replica can be created in B2. If one particular partition is available in B1, the replica can be created in B2. But if one particular partition is available in B0, the replica will not be sitting in B1. Okay, so this is the problem. This particular scenario will never arrive because of Kafka's rack awareness. So in terms of definition, we can say the rack awareness feature in Kafka spreads replicas of same partition across different racks to minimize data loss in the event of rack failure. Okay, just now what I discussed in a pictorial manner, that same definition we are writing here. So just remember this way, the replication of same partition is stored in different racks. If in one particular rack multiple brokers are running, then among those brokers the replica will not be sitting. It will be sitting in some broker where the broker is running in some other rack. Okay, like here B1, B2, B0, B2, this combination possible, but not B0, B1. So now we will try to understand the same concept with a very simple lab experiment. Okay, so here I will go to my notepad file where I have written some code. So let me first start a zookeeper and then show you how we can feel the concept of rack awareness with practicals. So here I am starting my zookeeper. Okay, now what we will do, we need to create multiple brokers, right? How to configure multiple brokers in our local system only, that I already covered. So let me just quickly do that. So here we are having server properties file based on which the brokers are spinned up in our local system, right? So if we want to create 3 servers for the same server file, we need to create 3 copy and then change accordingly. So here I will go to our Kafka directory and then I will go to config. Here if you see, the server properties is available. So I will copy that and here I will paste that. I will change the name. Maybe let me rename to server1 properties. Okay, and then here I will copy again and I will rename to server2 properties. Okay, done. Now the next step, what we need to do for storing the logs for different servers, we need log directory also. So here I will go to Kafka logs directory. Here we are having only server logs. So here I will update this to server logs _1. Okay, so server logs will store all the server logs for broker B0, and here server log 1 will be storing all the logs for broker B1, and one more we need for broker B2, right? B0, B1, B2. These 3 servers we will be having. Okay, that is done. Now the next step, we will again go to config, right? And then here we will open server.properties and we will edit some property. Okay, so it is our server.properties. So if you see, by default broker ID is 0, that is fine. Now here listener we will be uncommenting this one, so it will run in 9092 port by default. Okay, that is fine. And here if you see the log directory is pointing to server logs. So for our broker B0, all the logs will be getting stored in server logs. Okay, so here I will save this one. Then here I will edit server1 properties. Okay, so for our broker 1, here listener port we need to change. Port will be maybe 9093 for example. The broker ID we need to change. Different server cannot have same broker ID. So broker ID I will configure 1. And then here another property we need to change, that is log directory. So here we created already 3 different folders, right, for different logs. Server logs 1 is for broker 1. So here I will write server logs 1. Okay, and I will save this one. Similarly, I will make the changes for our server property 3. Okay, that is basically for server 2 we will change. So here broker ID, it should be having broker ID different, that is broker 2. The listeners will be here already 9092 and 9093 are used, so it is 9094. And then the last property what we will do, that is basically our log directory, server logs 2. So for broker B0, the logs are getting stored in server logs. For broker B1, the logs are getting stored in server underscore logs underscore 1. And for broker 2, the logs are getting stored in server underscore logs underscore 2. As simple as that. Okay, I will save this and close this. Okay, so here what we have done, create 3 server properties, that is done. Change the broker IDs, listeners and log directories, that is also done. So now we can spin up multiple brokers within our local system. Okay, so here I will start our first server. So here I will go to a new terminal and then here I will run this particular server properties code. Then here in a new terminal I will run this server.start.bat file only, but with different server file, that is server1.properties. So here you see our first broker is running in localhost 9092. Okay, now I will start the second one and then here I will start the third one also. The code what is running, that is same kafka-server-start.bat file, but the property file is different, server2.properties. Okay. So here if you see, this particular broker started at port 9093, and now this is our third server what we are starting, that will run at port 9094, right? So let's see. So here if you see, this particular broker is running at port 9094. So all brokers are started now. Now if you want to see what are the broker IDs running for your cluster, so you can execute this kind of code. Zookeeper-server-start.bat file. Here you need to pass where your zookeeper is running, and you want to print all the broker IDs, you can just execute ls command on top of it. Okay. So I will just do that quickly just to show you. Here anyway we know that the broker ID is running at 012 because just now we configured the broker IDs as per that. Okay, that is done. Now suppose we are creating a topic, and if you see the topic name, that is demo testing 2. Here the bootstrap server, we are configuring all the 3 broker URLs which are running in our local system. One is running in 9092 port, one is running in 9093 port, another one is running in 9094 port, right? And replication factor we are keeping 2, okay, so that we can understand the rack awareness funda. And the partition we are keeping only 1 for the simplicity purpose. Obviously you can increase partition, not at all a problem. Generally Kafka topic has multiple partition, but here we need to see same partition is available in same rack or in different rack. So one single partition itself is sufficient to do experiment with rack awareness, right? So I am just keeping partition 1, but replication we need to keep multiple to understand the rack awareness. So here I will create this particular topic. Okay, right? So here see, the topic got created. Now if you want to get some more information about the topic, you can simply execute this particular command, that is here kafka-topic.bat. That code only we are running with bootstrap server mentioning all our broker URLs. Just you need to describe the topic with topic name. So in this case the topic name is demo testing 2. So we are just giving that, and here we can paste this code to describe some information about this particular topic. So if you see, the replicas are stored in broker 1 and broker 0. Okay, even if you go to log location, you can see that. Let me show you. So here in F drive, Kafka logs, if I go, from the description we understood that it is stored in broker 0 and broker 1. Let's see. So let's go to broker 0 logs. Here see, demo testing 2 -0. -0 is indicating this is first partition of this topic, which is obvious, right? Because our topic is having only one partition. So only one folder is there for our topic, and that folder is available in our broker 0. What we can understand, because this server log is for broker 0. Now let's go to broker 1. So if we go to broker 1, the same partition, same topic will be available in broker 1 also, but not in broker 2. If I go to server logs 2, here that particular topic partition is not getting created, because in this case while creating the topic we configured replication factor 2, and in broker 1 and broker 0 only the data got replicated, so we no need that broker 2, right? So this is how replication happening, which we have seen in our previous video also. Now the question is, suppose this particular broker 1 and broker 0 are available in same rack. Maybe suppose that rack name is R1. Okay. Then what problem we might face? If suppose the rack has some issue, then whole topic itself will be not accessible. So based on rack awareness, what happens? That they make sure the replica of same partitions are available in different rack. Right? Now we will artificially configure such that the Kafka will make sure that broker 0 and broker 1 are in same rack. And then if we create a topic, we should not see 0-1 combination. We should see 1-2 or 0-2, this kind of combination. That is, in different racks the partition should be there. And how we will make sure which broker is running in which rack, that we need to artificially configure one property. Let's do that and let's experiment whether rack awareness is followed or not. Right? So for that experiment, what I will do, I will stop the brokers, whatever running. So here broker 3 stop, here broker 2 also I am stopping, and here broker 1 also I am stopping. So here all brokers are stopped. Now which broker will run in what rack, that if you want to configure, there is a property what you need to add in server properties, that is broker.rack. Using this you can configure which broker will run in which rack. Okay, so what we will do, for two different brokers, we will configure same rack, and for another broker, we will configure different rack. And then if we spin up all the brokers and if we try to create topic, then we should not see in the same rack the replica partition is available. It should be available in some different rack, right? So what I have written here, that we need to set broker.rack equal to 1 for broker 0 and broker 1. So that way I will configure that broker 0 and broker 1 will run in rack 1. Okay, so let's quickly do that. So here I will go to Kafka config, and then here in server properties I will open this. So it is for broker 0. Here you can see broker ID 0. Here we are configuring broker rack 1. Okay, that is done. I will save this. Same we will do for server 1, which is basically for our broker 1. You can think earlier one was broker 0, this one is broker 1. You can see also, right, broker ID equal to 1. Here broker rack also we are configuring as 1. So that way our broker 0 and broker 1 both will be running in rack 1, right? And then here in server 2, that is our server property for our broker 2, there we will configure a different rack. Suppose broker.rack equal to 2. Okay, we have saved this one. Now what we will do, we will start all our brokers again. So here the broker 0 using server.properties we are starting. It will run in rack 1. Okay, right? Then here the broker 1 we are starting with server 1.properties. So it will also run in rack 1. Okay, and the third broker, let's start. Here we are starting with server 2.properties. It will run in rack 2. Okay, and now we will try to create some topic with the bootstrap URLs, that is all three broker URLs will be passing. And then if we describe that topic, we should not see any combination of 0, 1, because 0 and 1 both brokers are running in same rack, right? So based on rack awareness principle, the replica for a same partition should not be available in the same rack, because if the whole rack goes down, the complete partition itself will not be accessible, right? So let's create multiple topics now, and let's see whether they are getting created in different racks or not. So here I am creating a topic of demo testing 3 with same properties, replication factor 2 and partition 1. Okay, so here I will paste that, and then here I can use describe command to see in what brokers the replica of the partition got created. Okay, so here demo testing 3 got created, and here we are describing the topic demo testing 3. We should not see 0, 1 combination, right? So see the replicas, it is showing 1, 2. Okay, so that means in broker 1 the partition is available and same partition replica is available in broker 2. Okay, right? Then here let me create another topic demo testing 4, and we will describe the demo testing 4 topic only. So here the topic got created and we are describing here. So here also it is 1, 2. Okay, then let me create another topic and let me try to describe this. So here you see the replica become 2, 1. Okay, let me try to create some more topics to show you that 0, 1 combination will not appear. Suppose demo testing 6, and here also demo testing 6. So see again 1, 2. Okay, like that if we create multiple topics, we are not able to see the combination of 0, 1, right? So see here we created one more topic demo testing 9 we created with same code, just the topic name we changed. Here bootstrap servers we have provided, replication factor, partition, and then if you are describing that particular topic, here we are getting replicas available in 0, 2. So 0, 2 is also a valid combination. 1, 2 is valid combination, but not 0, 1. You will never face 0, 1 due to rack awareness property. I hope you got the essence, the fundamental idea. This is very important because these concepts will help us in building a clear picture about the working of Kafka, how it is fail-safe, why big companies are using this reliable system, right? So just try to do this experiment in your local system so that you will get a clear picture out of it. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.